So in this problem, the challenge is to figure out what this 1,650 kilograms of stuff is. Well, that 1,650 kilograms is steel. And some of that steel, 3.19% of that steel, is iron, we're told. And it's iron that's going to react with oxygen. So we need to figure out the mass of iron that's in 1,650 kilograms of steel. So we're going to convert to grams first. Then we're going to turn that percentage into a conversion factor. And that's easy, 3.19 grams of iron per 100 grams of steel. It's the part out of the whole thing, or it's the amount out of 100. Now that we're in grams of steel, we need to convert to moles of steel. It's a stoichiometry problem, so that's always going to be a step. We're going to use a mole ratio now to convert to moles of oxygen. I'll tell you why we're converting to moles of oxygen in a minute. There are other ways to solve this problem. This is just my preferred method. We're going to convert to grams of oxygen, and then we're going to convert to kilograms of oxygen. Now, if you look closely here, we multiplied by 1,000 here, and we divided by 1,000 over here. And so because of that, we really didn't need to convert to grams and then back to kilograms. So that 22 kilograms of oxygen is all going to react with the iron here that's in the steel. So this pile of steel is going to increase in mass by this 22.6 grams. So down here I'm adding that grams or that mass of oxygen to the total. And then of course we have to deal with significant figures in the addition rule, and the 1650 is only precise to the tens place. So our answer can only be precise to the tens place, which is where we get the 1,670 kilograms from. And that is the total mass of that heap of steel over here after the iron reacts and has a synthesis reaction with that 22.6 kilograms of oxygen.